The purpose of this study is to analyze the liquefaction potential in Sepaku District, North Penajam Pasir Regency, East Kalimantan Province, which was appointed to be the next capital city of Indonesia. In this study, we use cone penetration test data, which consists of two main parameters. The first one is cone resistance and the second one is solid friction. We also use seismicity data of the study area, which are peak ground acceleration value and the magnitude of the earthquake happen around the area. And to analyze the liquefaction potential, we use empirical method which formulated by Sid and Idris in 1971 and Robertson and Wright in 1998. And this method is basically compares the two calculated variables. The first variables is cyclic stress ratio, which represent the seismic demand of the liquefaction, and the second one is a cyclic resistance ratio, which represent the soil resistance towards the liquefaction. And the comparison between the two variables is represented by factor of safety, or FS, which will be used to calculate the liquefaction potential index, or LPI value, which will be classified into 4 classes based on the classification made by Iwasaki in 1981, and the LPI value is also used to make the microzonation map. Then if we see the result of the study, in general, that the liquefaction occurs in sand and silt soil layers, but doesn't occur in clay soil layers because sand has coarser and larger grains of soil particles, so that it has more pores and cavities among the grains. The pores will be filled by the water, which can disrupt the connection among the grains as a result of being triggered by an earthquake. And the liquefaction of soil layers varies from 0.2 meters to 4.6 meters with the average thickness for about 1.21 meters. And we can say that the LPI value tends to increase with increasing magnitude, which indicates that the earthquake with a larger magnitude will tend to cause a liquefaction rather than the earthquake with a lower magnitude. And if we see the microzonation map, we can divide the research area into 2 classes, which are the high-risk area and the low-risk area. The research area in the southeastern part have a higher liquefaction potential than the northwestern part, because the northwestern part is consist of sand to silt soil layers. Meanwhile, the southeastern part is has a thicker silt to clay layers, so that the potential for the liquefaction in the northwestern part is lower.